Good evening, I am Mr. H. Thank you for joining me for this video. We're looking here at graph interpretation, and you know most standardized exams always have questions like this where you're given graph data and you have to analyze it or interpret it. We have a graph over here of population count. Population is increasing here along the y-axis and time is increasing here along the x-axis. There's like a specific piecewise function which has several portions and it has been split into these intervals A, B, C, D. We have to identify and answer these questions. We have to identify where 1, 2, 3, 4 is occurring. If you're looking here at population of this specific species or whatever it might be, let's start here with number 1. We have to identify where on this graph the population is changing. When you're looking at population is changing, you're looking here at changes here along the y-axis with respect to the interval. You know very well if you look here where the population is changing for the higher or for the lower amount or where it's increasing or decreasing. You see for question number 1, population is increasing here in interval A because you have an increase in the population count, the y value changes. Then of course it's occurring and changing here in the C interval where it increases quite a bit along the y-axis. You have to look at everything here from the start to where it ended. For interval A, it started here along the y-axis and it ended right here. For interval C, it started here on the y-axis, but it ends up right here. So there's definite change here in the population. And lastly, in interval D, you're starting from a higher point along the y-axis and you end up at a lower point. So the answer to your question 1, where the population is changing, is A, C, and D. And that would have to be right. Now let's look right here at number 2. The rate is constant. When we're talking about rate, we're talking here about slope. Where is a slope constant? Slope can be constant and uniform where if you have two specific x-axis values in the same interval, you were to calculate the slope and then you pick another bunch of values in that same interval, the slope would not change. The slope does not change where you have a straight line. I see a constant slope here in 3 intervals. In interval A, interval B, and interval D. Even though here the slope here and the line here is flat, the slope being 0, it's still constant, and here it's linearly constant, and here in interval D this decline is linearly constant. So the rate here is constant for wherever in the function here you're seeing straight lines. I see straight lines here in interval A, B, and D. So that would be the answer to number 2, A, B, and D. And now number 3, rate is not uniform and not constant. So where in this specific function do we see that the rate is not uniform and it is not constant? It would have to be right here. This exponential portion where you have an ever increasing rate of change where the slope in itself is changing based on where you are in that interval, and the answer to number 3 here would be C because it's an exponential function over there. The rate is always changing, it's never consistent, it's never uniform. Lastly, number 4, population is not changing. Where would the population not be changing? Where you would experience and see that, it would have to be right here. The population is not changing where the rate is equal to a very constant number and it's 0. The slope here is equal to 0. The rate is equal to slope, which is equal to 0. The number of people dying or the number of animals dying and the number of animals which are born is the same. There's no net effect. In interval A, you have a positive net change. In interval C, you have a positive net change. In interval B, you have a no net change. And in interval D, you have a negative net change, which means people are dying or animals are dying more so than they are coming in. Here, you have a net increase in the population, net increase in population, no change in population. Our second and last graph interpretation question for this video is this right here. On the y-axis we have a value of a specific car, how much it's worth over a time. This right here represents here the value of your car when you first purchased it, and at a specific time we can even get this an arbitrary designation here of 10 years, and you know here we're looking at 0 years. Initially it's worth a good amount of money, but over time the value declines. We have 2 models here of depreciation, how something devalues over time. A, the dotted line, B, the solid line. A, very well, if someone were to ask you to analyze it, A, very well here would represent a linear depreciation because something is uniformly changing with respect to value over time. The value here is very uniformly decreasing over time, and you can see that it is uniformly decreasing with time. There's a certain amount which it decreases, and it's the same amount every year. If it decreases by like $1,000 every year, it doesn't matter what you're in. from the previous year, the value has depreciated another $1,000. So it's uniformly decreasing. When you're looking at B, you see an exponential here, an exponential decrease in the value. And that right there is perhaps not a very good thing, because when you first buy the car, within 1 or 2 years, we can imagine this is 2 years, a very good percentage, or you can say 50% of your car's entire value you've lost already after 2 years. And now in the remainder of the years, the decrease in value will be a little less in terms of the rate, but you lose too much initially. So if someone were to ask you which of these represents a uniformly decreasing rate of depreciation, you would have to go with A, because you have a straight line. If someone were to ask you which one represents a rate of change which is constantly changing with time, you would have to go with B, because that represents an exponential decline. Remember here, for the exponential decline, very early on you're losing too much of your amount of value of your car, but later on in the later years you lose a little less with each year and you steady out a little bit. With the linear model, you're losing a same amount every year uniformly, and that difference has to be kept in mind. So it all depends on what your preference is. For some people, the linear depreciation is good. For others, exponential is good. Either way, you start at the same value, you end at the same value. It's how much value you lose or how quickly you lose it in the interim period is what creates this difference here with regards to both of these models. That's it for this video. Thank you for watching. Have a nice day.